Hi there. Today's lecture will be about the geometric derivation of pi. Okay. Say, just what the heck is pi anyway? Pi is the relationship between a circle's circumference and its diameter. So we can say that pi is the ratio of C, right, circumference of C to D, which is more usually often expressed as a fraction of C over D. Now in mathematics, we normally use, instead of a diameter of the circle, it is usually more convenient to deal with the radius, which is 1/2 the diameter. This is R. So then pi equals, also equals, C divided by 2R. Okay, let me check my notes here. I've actually had to work this lecture out a few times to make it more coherent, stepwise fashion. Okay, now in mathematics we also very commonly use a thing called the unit circle, which is a circle with a radius of 1. So R equals 1. Now in the special case of R equals 1, then we have pi equals C over 2 because the R just drops out. Okay, now for a geometric estimation of this, if we take the circle, the only thing we know about it is this distance from the center to the edge is 1. If we want to geometrically estimate, determine the distance around the circle, the method is to construct polygons that circumscribe the circle. Oops. And the simplest polygon is a triangle. And then if we can determine the length of the perimeter of the triangle, of the polygon, we can get an estimation for the length of the circumference of the circle. And if we use polygons with more and more sides, this gap here becomes smaller and smaller. And as the number of sides of the polygon increases, the approximation of the circumference of the circle gets closer and closer. So, with 3 sides here, how would we figure out the perimeter of the triangle? And if we use an equilateral triangle, all our polygons will be regular polygons, which means all these angles will be the same. So in a triangle, equilateral triangle, all of these angles is 60 degrees. Now if we draw a line from the point of one side of the triangle to the center of the triangle, and then out to the middle of the other side, we know that this angle is 90 degrees, we know that the length from the center of the circle to the point where the polygon meets the circle is just the radius of the circle, so that will equal 1. We'll call this A. A equals 1. Now if we draw another line similar to the first from the point to the circle, to the center of the circle, again to the middle of the other side, we know that this line divides this angle just exactly in half. So if our full angle is 60 degrees, we know our half angle here will be 30 degrees. So then we know this angle, because the sum total of a triangle, of any triangle, each and every triangle, the sum total of all the angles in the triangle is 180 degrees. So we have 90 degrees. We know this to be 30 degrees. That leaves 60 degrees for our angle theta. When dealing with trigonometry, it's common to call our unknown angle, or you know, the angle we're using, theta. So now with this information, what we want to find out is this distance here, this leg of the triangle here, which we will call B. And we just use regular old trigonometry. We only need to know two things about the triangle. For dealing with a right triangle, we only need to know two other things. The angle and the distance will serve. So I actually had to look up, grab my trigonometry book off the shelf and review a chapter. And I found that in order to find B, using A and theta, is very simple. A times tangent theta equals B. Okay, so once we have B, how do we determine the perimeter of the triangle? Well, B times 2 will be one side, and then 2B times number of sides will equal the complete perimeter of the triangle, so that'll be 6B. So if we call the perimeter C, we would have 2B times the number of sides, if we call N, the number of sides then 2B N A tangent theta equals C. Nope, I doubled that. Two BN. Well, actually, let's just call this 2N B equals C. Okay, so now if we sub in our equation for B, we have 2NA tangent theta equals B. Now, then we're just setting up the framework here. We're going to end up with a very simple equation which we can then progress on. So, you know, we have to wade through the algebra here to get to our nice little equation. What was I thinking? As we increase the number of sides, how do we track theta? So theta here is, the number of sides is 3. 360 divided by 3 is 120. And we want 120 would be this angle here, right? We want 1/2 of that. So we want 360 divided by 2n equals theta. This can be simplified into 180 n equals theta. Okay, so now we substitute theta, or equation for theta, into this, and I'm running out of space here. So we'll have 2n 2a n times tangent 180 over n that equals our approximation of pi. Now this can be simplified further too, because we know a is the radius of our circle. It's always going to equal 1. So we can just eliminate a from the equation. Oops, this is not approximation of pi. This is actually the perimeter. We'll call it C. This is actually the perimeter of our triangle. Now we know from down here, in the special case where r equals 1, the value of pi equals the circumference, or the perimeter, divided by 2. So then this again becomes 2n tangent 180 over n equals c, and we want to extract the value of pi from this, so we put both sides over 2. This simplifies to n tangent 180 over n is our approximation of pi. This is our what we wanted to derive. Okay, now we can clean this all up here and start working. We'll copy this over here, and tangent 180 over n approximately pi. Now we can draw a little graph here, n and our approximate value for pi. Okay, so we break out our calculator, a little $5 handy duty calculator, and for a polygon with 3 sides, A, we can forget about A because it's always equal to 1. So we have 180 divided by n is 3, so we have 60 tangent 60 times 3 equals 5.196. We'll call it 5.2. So for a 3-sided polygon, our approximation of pi is 5.2. Now the idea here is to increase the number of sides on a polygon and watch what happens. We can consider that a circle has an infinite number of sides, so we know that for an infinite number of sides, the approximation will be infinitely close, and that will equal 3.1415926, blah, blah, blah. So we want to see how the progression of increasing the number of sides progresses towards the final value, that we all know for the constant. So 180n is 60 with 3 sides, 5.2. So let's now take this to 4 sides and see what happens. Circle, and we have 1, 2, 3, 4. Okay, radius. We know this angle is going to be 45. R equals 1. We want to find B here. Okay, so 180 divided by 4 equals 45. 45 tangent is 1. B equals 1 in this case. And 4 times 1 is 4. So with 4 sides, our progression towards the final value has already started. And let's jump to 6 sides. Okay. 1, 2, 3, 4, 5, 6. Well, this is actually A here. It's 1. Theta equals 180 degrees divided by 6 is 30. 30 degrees from here. B. Okay, B 30. Tangent 0.57. We'll call it 0.58. Times n, times in this case is 6. So we're down to 3.46 with 6 sides. 3.46. See, pretty orderly, steady progression towards the known value for pi. Now, let's just say, and we'll abbreviate the diagram on this one. We'll jump to 20 sides. The circle is going to be going like this. And we know A equals 1. And for 20 sides, 180 divided by 20 is going to be 9. In this case, theta equals 9 degrees. Okay, so tangent 9, B equals 0.16 times 20. And for 20 sides, our approximation of pi is 3.1 7. Okay, so at 20 sides, we're getting pretty close. We're within, 3/100ths of the precise value for pi. And again, right, our number of sides, it's very easy. It takes 10-15 seconds to calculate on the hand calculator. You pick a number for a number of sides, and 180 divided by that number, take the tangent of that, multiply by a number of sides, gives you your approximation for pi. So, just for giggles, let's take this out and say, for 1,000 sides, what's our approximation of pi? 180 divided by 1,000 equals 0.18 tangent times 1,000. 1,000 sides equals 3.1416. So with 1,000 sides, we're good out to 4 decimal spots, and then we're only off by 1/10,000th, 3.1415, which is actually it's within 100,000th, right? 6059. So for 1,000 sides, we're good to, we're within 1/100,000th of the value of pi. Okay, so for a few more giggles, let's go to 10,000 sides. Oh, let's go straight to 100,000 sides. Okay, a handy-duty calculator. 180 divided by 100,000 equals tangent times 100,000 equals 3.141596, right? And the calculator says 5. I only memorized pi out to 8 significant digits. But this is for any practical purpose, any engineering or calculating purposes. 8 digits is more than enough, more than sufficient. So with a simple hand calculator, you can estimate the value of pi using this simple equation to any desired degree of accuracy. Now, for a more mathematically rigorous definition of pi, we can define the exact value for pi as a limit. We take the limit of n times tangent 180 n as n approaches infinity. And this would be a mathematical, rigorous, one of them, formula for the precise value of pi. Okay, there you have it, a geometric derivation for the value of pi. I hope you enjoy it. Thanks for watching, and I'll see you next time.